For over a century, astronomers suspected Betelgeuse wasn't traveling alone. A faint, predictable wobble in its behavior kept hinting at a hidden companion, something small and dim, buried inside the glare of one of the brightest, most famous stars in the entire night sky. Nobody could actually see it. Then, within the span of about a year, 3 completely different observatories each caught a piece of it, first predicting exactly where it had to be, then photographing it directly, and finally catching the literal trail it leaves behind as it moves. Stick around, because I'm going to walk you through exactly how astronomers finally confirmed Betelgeuse's hidden companion, why it took 3 separate telescopes working together to pull it off, and why proving this star exists actually helps explain some of Betelgeuse's own strangest behavior. And if you want more of these deep dives into real published research instead of recycled headlines, go ahead and subscribe now, because there's a lot more coming out of the study of one of the most famous stars in our sky. To understand why confirming this companion star was such a genuine challenge, you first need to understand exactly what makes Betelgeuse itself so difficult to study in the first place. Betelgeuse is a red supergiant, a star nearing the end of its life, roughly 642 light-years from Earth, marking one shoulder of the constellation Orion. It's almost unimaginably large, big enough that if it replaced our own sun at the center of the solar system, its outer layers would swallow up the orbits of Mercury, Venus, Earth, and Mars, potentially reaching out past Jupiter. That enormous size comes with real instability. Betelgeuse's outer layers are turbulent and constantly shedding material, and the star itself brightens and dims across multiple overlapping cycles, most famously during 2019 and 2020, when it dimmed dramatically enough that some astronomers wondered whether it might be approaching a supernova. Later analysis determined that specific dimming episode was caused by a cloud of dust the star itself had ejected, temporarily blocking part of its light, rather than any sign of imminent explosion. Buried within all of that chaotic brightness and turbulence, astronomers had long noticed something else, a secondary pattern layered on top of Betelgeuse's main pulsation cycles, a roughly 6-year rhythm that didn't fit neatly into any explanation involving the star acting alone. That kind of secondary periodic signal is exactly the sort of clue that suggests an orbiting companion, some second object tugging gravitationally on the system and leaving its fingerprint in the data, even without ever being directly seen. If you're finding this as fascinating as the researchers involved clearly are, drop a comment and let me know, because it genuinely helps me figure out what other space stories are worth covering next, actually confirming that suspicion required an extraordinarily difficult observational feat. Betelgeuse is so overwhelmingly bright compared to any plausible companion star that directly seeing something faint sitting right next to it is a bit like trying to spot a lit match held directly in front of a stadium floodlight. The breakthrough came from a research team led by Steve Howell, a senior research scientist at NASA's Ames Research Center. Rather than trying to see the companion directly first, Howell's team worked backward from the 6-year periodic signal, calculating exactly where a companion star would need to be at, a specific moment for astronomers to have any realistic chance of spotting it, catching it near the widest possible separation from Betelgeuse in its orbit. Using the Gemini North telescope in Hawaii, paired with a specialized high-resolution camera called Alipec, specifically designed for exactly this kind of high-contrast imaging challenge, Howell's team captured a faint point of light exactly where their calculations predicted it should be. That result, announced in July of 2025, marked the first real observational evidence directly supporting a companion that had been theorized for more than 100 years. The team gave the newly confirmed star a name fitting its host, Siwarha, meaning her bracelet in Arabic, a companion piece to Betelgeuse's own traditional name, which translates roughly to the hand of Al-Jawza. One discovery on its own, however compelling, generally isn't considered fully settled in astronomy until independent confirmation arrives from a completely separate team using different equipment. That confirmation came a few months later from a team led by Miguel Montargis at the Observatoire de Paris, using the European Southern Observatory's very large telescope in Chile. Specifically, its SPHERE instrument, a system built with extreme adaptive optics technology originally developed for directly imaging exoplanets around other stars. Montargis' team timed their observations for December 3rd and 6th of 2024, deliberately chosen to coincide with the predicted point of maximum separation between Betelgeuse and its hypothesized companion. They captured it clearly. According to Montargis, the team had genuinely doubted going in that their instrument would even be sensitive enough to detect a companion as faint as originally predicted, and the fact that they succeeded turned out to reveal something unexpected in itself. The companion star is actually more massive and considerably brighter than the original theoretical models had anticipated. Montargis described the moment in terms that capture just how significant a confirmed direct image like this is within the field, calling it one of the best moments in science, the experience of seeing something genuinely new and unexpected. The results were published in the journal Astronomy and Astrophysics in 2026. Even with two independent detections in hand, one more piece of confirmation arrived that turned this from a confirmed point of light into a fully understood physical system. A research team, led by astronomer Andrea Dupree, used the Hubble Space Telescope, combined with additional ground-based observations from the Fred Lawrence Whipple Observatory in Arizona and the Roque de los Muchachos Observatory in the Canary Islands, to search for something considerably more subtle than the companion star itself, the physical trail, or wake, that a companion star should leave behind as it moves through Betelgeuse's own enormous, extended outer atmosphere. Dupree's team found it, detecting a distinct pattern of changes in the light passing through that outer atmosphere, corresponding to a trail of unusually dense gas stirred up by Siwarha's passage. Dupree described the effect using a comparison that's stuck with a lot of people, covering this story since, comparing it to a boat moving through water, with a companion star creating a visible ripple effect in Betelgeuse's atmosphere that shows up clearly in the data. According to Dupree, this represented the first time researchers had captured direct signs of that wake, confirming not just that Siwarha exists, but that it's genuinely embedded within and actively interacting with Betelgeuse's own outer layers as it orbits. Those results were presented at the 247th meeting of the American Astronomical Society in early January of 2026, with the full study expected to appear in the Astrophysical Journal. It's worth explaining why finding that wake specifically mattered so much, beyond simply adding one more confirmation to an already fairly solid case. A single faint point of light captured in an image could, in principle, still be explained away as something else entirely, a coincidentally placed background star, or some kind of instrumental artifact that happened to survive multiple rounds of careful analysis. A physical wake, a detectable disturbance actively rippling through Betelgeuse's own atmosphere in exactly the pattern and timing a real, physically interacting companion star would be expected to produce, is a considerably harder thing to explain away using any alternative, non-physical explanation. Between Gemini North's initial prediction and detection, the Very Large Telescope's independent direct image, and Hubble's confirmation of an actual physical wake disturbing Betelgeuse's atmosphere, researchers now have three genuinely independent lines of evidence, gathered using three different instruments and three different techniques, all pointing toward the same conclusion. There's still one more round of verification planned before the case is considered completely closed, and it's worth explaining why. According to Montargis and his collaborators, fully confirming that the object detected really is gravitationally bound to Betelgeuse, orbiting it the way a genuine companion star should, requires observing it again roughly a year later on the opposite side of its orbit from where it was first detected. If the object shows up in exactly that predicted position during a follow-up observation, it would essentially eliminate any remaining possibility that astronomers happened to catch an unrelated background object, drifting past by pure coincidence. Montargis has described the remaining room for doubt as very little at this point, but the team has been careful to treat that final confirming observation as the last necessary step before declaring the discovery fully and completely settled. Siwarha itself, once fully confirmed, will periodically become difficult to observe again as its orbit carries it back into Betelgeuse's overwhelming glare. And researchers have specifically noted it's expected to become visible once more in 2027, with follow-up observations already being planned to take advantage of that next viewing window. It's worth situating this discovery within a broader pattern in astronomy, because confirming a companion star predicted purely from indirect evidence, decades before it was ever actually seen, represents a genuinely satisfying category of scientific achievement. Astronomers had good theoretical reasons to suspect Betelgeuse wasn't alone for a very long time, based purely on subtle periodic patterns buried in its brightness data, but suspicion isn't confirmation. And for over a century, no instrument existed capable of actually resolving something as faint as a companion sitting this close to a star, this overwhelmingly bright. It took the combination of a precisely timed prediction, an extreme adaptive optics system originally built for an entirely different purpose, and a space telescope, sensitive enough to detect a subtle atmospheric ripple, working together across multiple observing campaigns to finally turn a century-old suspicion into a confirmed, independently verified physical companion. So, what does all of this actually add up to? One of the most famous, most heavily studied stars in the entire night sky turned out to be hiding a genuine secret in plain sight for over 100 years, a faint companion star close enough to physically stir up Betelgeuse's own outer atmosphere, confirmed not through any single dramatic breakthrough, but through three separate observatories, Gemini North, the Very Large Telescope, and the Hubble Space Telescope, each independently contributing a different piece of evidence that, together, finally closed the case. If stories like this one, grounded in real published research and honest about which telescope actually did what, are what you want more of, subscribe to this channel and turn on notifications, because Siwarha is expected to swing back into view in 2027, and there's a real chance that next observation delivers the final, decisive confirmation this entire investigation has been building toward. Thanks for watching, and I'll see you in the next one.